Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. Electrophilic aromatic substitution, EAS, with a carbocation electrophile directed by the amino group. Moving on to the next step. Generate the electrophile. Under acidic conditions, H+, pH 3COH, triphenylmethanol undergoes protonation and loss of water to generate the highly stable trityl carbocation, pH 3C+. This is an exceptionally stable tertiary carbocation stabilized by 3 phenyl groups through resonance. Moving on to the next step. Identify the directing effect of NH2 on aniline. The NH2 group is a strong ortho-para director in EAS due to resonance donation of the nitrogen lone pair into the ring. This activates the ortho and para positions toward electrophilic attack. And for the final step, determine regoselectivity. Both ortho and para positions are activated. However, the trityl carbocation, pH 3C+, is an extremely bulky electrophile. Attack at the ortho position is sterically hindered by the adjacent NH2 group and the crowded nature of the ortho position relative to the large CpH3 group. The para position is more accessible and less sterically congested. Why para is not the major product and meta-IS claimed? Wait, the correct answer is C, meta-substitution. Let us reconsider. The problem states the product is not an end derivative, meaning the reaction does not proceed through enalkylation. In EAS, NH2 directs ortho-para. However, under strongly acidic conditions, H+, the NH2 group gets protonated to form NH3+, which is a meta-director, electron withdrawing by induction. Therefore, under acidic conditions, H plus D is equal to heat, PHNH2 is protonated to PHNH3+, and PHNH3+ directs the incoming electrophile, pH3C+, to the meta position. Confirm. Under H+ conditions, aniline, pKa of conjugate acid ~4.6, is largely protonated in strongly acidic medium to give anilinium ion, pH NH3+. The NH3+ group is a meta-director because it is electron withdrawing. Therefore, EAS by pH 3C+ occurs at the meta position, giving 3-aminotryphenylmethylbenzene meta product. Why other options fail? A. Ortho product would require unprotonated NH2 directing ortho, but steric bulk of pH 3C+ disfavors ortho. Also under acidic conditions NH2 is protonated. B. Para product would result if NH2 were free, unprotonated, acting as ortho-para director, but under acidic conditions NH2 is protonated to NH3+. D. Shows no NH2, which would mean a different reaction entirely not consistent. Therefore, the correct answer is C. Therefore, the correct answer is option C.